Hi, everyone. My name is Jack Statza. I'm a senior principal here on Alumni Ventures Blockchain Fund. Today, with my colleague Sophia Zhao, we will go over Web3 infrastructure and why it's still an important space for development and investment. So let's get into it. So much like how, as an internet user, you don't need to understand how HTTP, SMTP protocols work to surf the web, the same case could be made for blockchain infrastructure. You just want the application to work seamlessly with blockchain working behind the scenes. However, for the next disruptive Web3 application to exist and be brought mainstream, it requires a secure, fast, and decentralized infrastructure. Similar to how Uber wouldn't have existed without the iPhone as a platform, blockchain technology could unlock new applications that wouldn't have been previously imaginable. In this video, we'll define the space, share with you our investment theses, some key numbers, trends and opportunities, and other topical subjects related to Web3 infrastructure. The evolution of the web came in three phases. Web 1 was the period between the 1990s and early 2000s where we saw open protocols like HTTP, SMTP, and FTP. Web 2 was characterized by the insurgence of social media behemoths like Facebook, Twitter, and YouTube. In Web 2, people began creating and posting their own content, actively participating in the internet rather than passively reading it. But most of that activity ended up being distributed and monetized by big companies, which kept most, if not all, of the money and control for themselves. The infrastructure of Web 2 was and is centralized cloud infrastructure that is defined by AWS, Google Cloud, and Microsoft Azure. Web3 is an idea for a new iteration of the internet, which incorporates concepts such as decentralization and token-based economics. Web3 will replace the centralized corporate platforms we see in Web2 with open protocols and decentralized community-run networks, combining the open infrastructure of Web 1 with the public participation of Web 2. If the Web 1 era favored publishers and the Web 2 era favored platforms, Web 3 is all about tilting the scales of power and ownership back towards creators and users. The foundation of Web 3 infrastructure is the blockchain. Blockchains act as a shared computer and storage network. Transactions are processed on-chain through smart contracts, and the results are then also stored on-chain, packaged into the blocks that are validated and committed. Blockchains optimize among three major constraints, namely decentralization, scalability, and security, referred to as the Blockchain Trilemma. The Blockchain Trilemma problem is the situation where as blockchains, which are layers 1 through 3, gain adoption, they generate more data that all full nodes must store. This causes issues including increased centralization, which acts as a burden because you have to run a full node, and that will get too high when you run a full node of data. Limited scalability to ensure the network remains decentralized. Decreased security as more users run light clients over full nodes. And to overcome this problem, a blockchain would need to exhibit the following. First, it would need to incentivize nodes to store history and allow the network to remain decentralized. Second, it would need nodes to share the burden of storage, which would allow the network to scale with more users. And third, it would need to allow stake nodes to compute the state and give light clients the same security as a full node. To address the trilemma, new blockchains came out to address storage, scalability, and security. But let's take a step back to think about what blockchain layers mean. Consider a below diagram with houses. Each house, or layer 3, represents the applications you find in the blockchain world: NFTs, metaverse, decentralized finance. And all these are built on a specific layer 1 or 2, referred here as layer 1 for simplicity. But these blockchain protocol examples would be like Bitcoin and Ethereum and Solana. These layer 1s represent the foundations that these houses are built on, which means, they can't connect to the other foundations, which are other blockchains. So this exhibits that, right now these homes don't have a bridge to connect the data to each other. And this is exhibited in the real world where you need to go to an exchange to convert your Bitcoin into Ethereum. Bitcoin has its own foundation. Ethereum has its own foundation. There's no bridge connecting them. But that's where layer zeros come in. Layer 0 is the ground or earth which all the foundations for these houses are laid upon. It shares a common historical database by housing all past transactions across blockchains, so those Layer 1 blockchains and respective applications can continue to have cheap and fast transactions. In layman's terms, this just means they're offloading historical data to the Layer 0, so then all that data isn't clogging up the transaction blockchains in real time. So by being the unifying Layer 0 for these houses in this description and foundations, Layer 0s can enable multiple chains to interact with each other without the need to go to an exchange. So this area is still under a lot of innovation, but it's an exciting time to see what comes out of it, because Layer 0 does enable multiple blockchains to talk together. Blockchains were not built for the level of demand we are seeing today. The Ethereum blockchain processes around 20 to 30 transactions per second, whereas Visa can process around 24,000 per second. Further, when demand outweighs capacity, transaction costs, called gas prices, skyrocket. There are many new blockchains or Layer 1s that are addressing this challenge. These new chains make trade-offs, often influenced by the different use cases these chains may cater to. As multiple blockchains develop in parallel, applications and assets tend to be siloed on disparate chains, creating walled gardens. For instance, if you have assets on Ethereum but want to transact on a chain that's not compatible with Ethereum, you'd have to transfer the asset to an intermediary, whether it's an exchange or a bridge that shuttles assets between different chains. Bridges, however, remain a risky proposition. For instance, in March 2020, approximately 600 million in ETH and USDC were stolen from a Ronin network bridge, the Ethereum-based sidechain for the well-known cryptocurrency game Axie Infinity. Now let's take a look at some important numbers to put things into perspective. We are still in the early days of blockchain adoption. Crypto's total market cap peaked at $3 trillion in November 2021 and is currently hovering around $1 trillion, which pales in comparison to the total size of global money supply at $90 trillion or global stock markets at $94 trillion. In terms of transaction numbers, Bitcoin's blockchain processes over 260,000 per day, while NASDAQ alone processes in excess of 30 million transactions per day. That said, Bitcoin's on-chain volume has increased 435% from 2020 to 2021, while Ethereum's on-chain volume has also increased 729%, respectively, over the same period. So supporting this transaction growth are 20,000 monthly active developers in the greater Web3 ecosystem. This number has doubled since 2021. Following the opportunities in promising new Layer 1s, developer activity has continued to grow exponentially in these nascent ecosystems. Developer counts grew 86% for chains outside the top 200, dwarfing Bitcoin and Ethereum's growth.
At the Blockchain Fund, we focus and prioritize picks and shovel opportunities that are key to scaling Web3 development. We're seeing new and innovative solutions that are addressing existing problems built on the works of their predecessors, paving the way for a multi-chain future that is more dynamic and distributed than the current state. And as we mentioned in the previous slide, developer interest in Web3 continues to grow, and we expect new dev tools and tech stacks such as the Web3 versions of AWS and Google Cloud platforms to emerge. And specifically, we want to highlight 3 trends that are taking shape. First is the concept of Layer 0. Currently, Layer 1 blockchains like Ethereum, Solana, Aptos have a hard time talking to each other. The architecture, implementation, and even programming languages used vary greatly from chain to chain, and this becomes incredibly difficult to manage the execution of transactions across the different consensus algorithms that these chains use. And this is where Layer 0 comes in. As my colleague Jack mentioned earlier, you can visualize this as the ground or the foundation, or Layer 1, for the houses or apps are laid upon. Layer 0 networks augment a blockchain's capability without interfering with its inner workings. More simply put, it lets blockchains talk to each other by creating this base layer that connects them together. Next, we have the modular blockchains. Imagine you are a car manufacturer and you're breaking the car assembly into smaller components that are handled by specialized teams, such as the engineering design team, the car body team, etc. Similarly, a modular architecture in blockchain is one in which the main responsibilities of transaction execution, consensus, and data storage are broken up and delegated to a network of independent blockchains or layer 2 channels. This is very different from the traditional or monolithic blockchains like Ethereum, where all these functions are performed by every node on the network. And as such, modular blockchains innovations can help address the blockchain trilemma. Lastly, there's also a huge movement to remove the technical overhead required to build on these blockchains in the form of defined APIs. These APIs abstract away low-level implementation concerns such as needing to run your own node and therefore reducing the length of development cycles. Within this space, we're looking for a few specific markers of success. First, horizontal scaling, for blockchains to be able to process more transactions simultaneously. Transactions are processed in parallel across multiple subsections of a blockchain called shards, but maintains a consensus among them. This means that instead of requiring nodes to have better hardware to process transactions faster, we are relying on having more nodes with lower hardware requirement instead. And this reduces the barrier for new nodes to enter, promoting decentralization. Secondly, in order to attract and retain developers building in Web3, we need well-written documentation and tools that are compatible with existing dev tools and existing virtual machines. Thirdly, the cost of using blockchain technology shouldn't be prohibitive. You may be aware of Ethereum's high gas or transaction fee that can be a barrier for adoption or transaction. For instance, the transaction fee of your remittance might be worth half of what you're remitting, or the transaction fee of your NFT purchase could be the same as your entire NFT purchase. Overall, we're looking for network designs that are enabling cheaper computing to help with increased adoption. And lastly, given the nature of the space, we're looking for startups with strong engineering teams, ideally executing on pioneering academic research that can be validated by technical advisors. And this is one sector where we can see novel implementations both at the cutting edge of market and academia. Looking forward, if we can find a way to make blockchain more scalable, secure, and fast, if this is possible, then we'll see many use cases transition to the blockchain. Currently, major enterprises such as PayPal, MasterCard are already experimenting blockchain adoption, and we look forward to seeing more traditional enterprises come into the space. And perhaps killer apps in gaming, digital identity, document verification, consumer education, etc. will trigger the next wave of adoption and attract more developers into the ecosystem, creating a positive loop. We might see a flourishing multi-chain world where transactions, data, and assets will flow seamlessly through them. And of course, on the flip side, if blockchain infrastructure development doesn't evolve for the better, then blockchains may be fundamentally flawed as a method of shared compute and storage. And likely the economics will not work out to the point of broad adoption. This could mean either the cost will be prohibitive to the point where users will not participate at the retail level, or there's not enough economic gain to warrant enterprises to invest in migration of their products and services. And or that blockchain may not be performant enough to support the real-time use cases that we are used to today, such as high-velocity financial system or responsive gaming. And lastly, the funding for the space might dry up as milestones of technical advancement or adoption are far and few between. And now we'd like to highlight two portfolio companies within the Web3 infrastructure space. The first one is Subspace Network. It is a next-generation, massively distributed, and decentralized infrastructure layer that aims to support Web3 at internet scale. Subspace introduces a novel architecture that can support millions of consensus nodes, which contribute their storage and computation resources to the network. In essence, subspace lets blockchains talk to each other. Blockchains like Ethereum store a huge amount of historical blockchain data on chain that impacts the network speed and fee, and subspace can help alleviate this bloat by storing transactions for Ethereum. And subspace can serve as an extra layer of transaction processing that any layer from layer 1 to layer 3 can use, and you can think of it like a blockchain of blockchains. The company raised $32.9 million in their early stage funding in March 2022, led by prominent investor Pantera Capital. Another portfolio company we want to highlight is Quai Network, which is an open source layer 1 proof of work blockchain network utilizing the capabilities of merge mining to increase throughput and security. Quai Network takes the novel approach to solving the blockchain trilemma through its shared security via merge mining across its integrated rollups. The Quai Network provides Web3 applications with high speed without compromising decentralization and security. Currently, Quai Network has over 20,000 node validators, which is substantially larger than any other layer 1 blockchains such as Avalanche, Polkadot, and Solana. This ensures the network is highly protected against network outages that many other layer 1 chains have suffered. Quai Network has raised $10 million in their early stage funding round in early 2022, led by Polychain Capital. If you'd like to learn more about Web3, here are some learning resources. A16's crypto site publishes food for thought pieces regularly, and their Crypto Canon has a collection of articles of building blocks, tech basics, foundations, and key concepts. Chainlink has a good article on explaining the blockchain trilemma and general approaches to scaling a chain. Alchemy has a good article to go deeper on modular versus monolithic blockchains, expanding on what we touched upon today in our deep dive. And for high-level updates or news highlights, you can subscribe to Delphi Digital, Masari, and Blockworks. In summary, blockchain technology will enable shared computing and storage for retail and enterprise use cases. The blockchain trilemma is a challenge that many innovators in Web3 are addressing in the hopes that we don't need to have trade-offs among scalability, security, and decentralization. We expect to see a multi-chain world in the future. And it's still early days, and the Web3 developer stack is still being discovered as we go. We look forward to smooth developer experience with well-written documentation and compatibility with existing dev tools and virtual machines. And if all things go well, we are at the nascent stage of a paradigm shift. Thank you for watching our deep dive, and we appreciate your feedback. Hope to see you at the next episode. Thank you.